In this video, we take a look at the utility nodes. I'm going to open up the shader network that is assigned to the geometries in the scene. And let's go down to the utility nodes. The first one is Black Body, which is a copy of the Pyro shader inside SideFX Houdini, and it basically emits a color based on Kelvin color temperature. Cache node can be used to avoid re-evaluating costly parts of the shading network. For example, if you have a huge volumetric sim going on, to avoid re-evaluating it all the time, you can cache it and connect the output of the cache node to the input of the next node in the chain. Camera projection allows you to perform camera projection of an image over an object. We can add an image node and load this floral1.png image and set it as the projection color input of the camera projection node, and set the camera projection as the beauty shader. Now this texture is projected through this camera. We can move the camera around to see that. We have this clamp node, which basically limits or clamps the input between 0 and 1. We used this in the previous lesson, if you remember, when we were making the sphere movement on X control, the base weight of our shader. You can check that out again. Next, we have facing ratio node. Let's add one and set it as the beauty shader. This shader outputs a value between 0 and 1 that tells you if the point being sampled is facing towards or away from the camera. A value of 1 means that it is facing the camera heads on. A value of 0 means that it is facing 90 degrees from the camera. So that is basically Fresnel effect, right? If you remember. So based on the incidence angle, you get outputs from 0 to 1. We have this bias, which allows you to offset the effect towards the frontal faces or the edges. And gain value controls the gradation between 0 and 1. So as I decrease it to a very small value, there would be no gradation, so 0 or 1. And as I increase it, the gradation becomes more and more. Layer float node lets you layer up to 8 float layers linearly. Next, we have this OSL shader, which lets you write your own shader using Open Shading Language using this simple editor here. For a more advanced code editor, you can click on this Open Editor button and write your code in this OSL editor or load OSL scripts from the file menu. We have this pass-through node, which evaluates any shading network connected to the evaluation 1 to 20 inputs. The pass-through input is evaluated first, which is normally a standard surface shader or any other surface shader. This shader is kind of useful to force the evaluation of parallel shading networks that are not part of the beauty pass, whose resulting value you need to store in an AOV. We take a more in-depth look at the pass-through node when discussing AOVs in the rendering section. Space transform node converts the input coordinates from one space to another. Switch RGBA and switch shaders allow you to define up to 20 inputs and choose between those inputs using this index value up there. Let me clean up the work area by deleting all these extra nodes. I'm going to add a switch shader and add two Lambert shaders. The first one can be pink and the other one can be orange. Set the pink shader as input 1 and the orange shader as input 2. Now, if the index value is 0, we use input 0, which is the pink shader. And if it is 1, we use the input 1 shader, which was the orange shader. Switch shader is for surface and shader inputs, but the switch RGBA is for color and RGBA inputs. We take a look at the trace sets later on in this lesson. We discussed triplanar in its own lesson previously. Then we have UV projection, which applies a UV projection to the texture input. Let me add an image node. Unload this floral1.png image again and connect it to the projection color input of the UV projection node. And now set the UV projection node as the beauty shader. In the UV projection node, let's change the coordinate space to object. And now we can have different UV projection types like planar, spherical, cubical, cylindrical, and so on. Then we have UV transform, which enables you to modify existing geometry UVs locally and controlling how a 2D texture is placed onto a surface. You can control the position, size, and rotation of an image on the surface using the scale, translate frame, and rotate frame attributes. You can also control how the texture is tiled within the frame using the repeat, rotate, offset, mirror, stagger, and wrap attributes. Let's set the UV transform as the beauty and connect the floral texture as the pass-through input. I can set the scale to 0.2 to make it smaller, or translate it on 3 axes or rotate it, and tons of other familiar settings. So the UV projection node basically gives you a new UV map, but UV transform adjusts the existing UVW mapping on your geometry. And using a vector map, you can connect a vector texture exporter from sculpting tools like Mudbox or ZBrush and adjust some of its parameters and then pass it on to the next node in the chain. For now, let's make sure no shader is used as the beauty shader. So a default Lambert shader will be used. And finally, we have trace set. We talked about this concept of trace set, which can be used to exclude objects from each other. Let's say I don't want to see any effect of the sphere on the floor or this backdrop object that we have. I don't want to see the shadows from the sphere on the floor. I don't want to see any GI contribution from the sphere on the floor. I don't want to see its reflection on the floor and so on. For this, let's actually open up the standard surface shader called backdrop, which is applied to the backdrop geometry. Now drag a trace set node to the work area. First, we need to define a trace set. Let's call this set sphere and connect the standard shader output, standard surface shader output to the pass through input of the trace set node. And set the trace set as the root. Now let's select the sphere and add an Arnold parameters tag. Down here you have trace sets. Let's have one trace sets. As you can see, we have a new field called value1 type sphere, or whatever name you have used in the trace set field of the trace set node. And now the floor only recognizes the sphere, and that is because this inclusive checkbox is enabled in the trace set node. Now if we simply disable it, the sphere will be excluded from the floor and they don't acknowledge the existence of each other basically. In the standard surface shader, if I increase the metalness value, you notice the sphere's reflection also is not visible on the floor, which is the case for other objects in the scene. So in this video, we learned about the utility nodes. See you in the next video.